Now we will see how the problems of combination is done. Combination simply means we have to select. We don't have to arrange. We have to just choose out things, no matter in what order they have been selected. So in combination we will be choosing out, we will be selecting out. You just see the formula for combination. Out of n things, if I have to select r things, it is NCR is equal to n factorial by r factorial into n minus r factorial. Suppose out of 10 students, I have to select 2 students, then it will be 10C2, that will be 10 factorial by 2 factorial into 10 minus 2 factorial, that is 8 factorial. In that way, we have to select certain number of items from a given number of things. See, there are 5 boys and 3 girls in a class. 5 students to be selected for a competition. How many ways selection can be made if no restriction is there? See how many total students are there. 5 plus 3, 8, and we have to select 5 students. Very simple, very easy. This is 8C5. So we can write this as 8 factorial divided by 5 factorial into 8 minus 5 factorial, that is 3 factorial. So first question, very simple, you can do. Just take care of the conditions given in the question and accordingly select the things. In the second question, 3 boys and 2 girls to be taken. What combination is there? 3 boys and means into. I said to you in the basic fundamental principle of counting that whenever the work is going on, we have to just multiply the things, multiply and multiply. Suppose in this question, I have to find 3 boys. How many boys are there? 5. Out of 5, I have to select 3. And the work is not complete. So into 2 girls to be taken. How many girls are there? 3. So out of 3 girls, I have to select 2 girls. So this is the way, number of ways in which 3 boys and 2 girls can be selected out of given 3 boys and 2 girls. Out of 5 boys and 3 girls. Okay. See in the third question, a particular boy is always selected. Suppose I got a call from a minister that particular boy has always to be selected. So I have a condition that I will be selecting the 4 other students because one boy is already selected. Now virtually what I am doing, I am just selecting 4 students out of the remaining 7 students. So remaining 7 students, I am selecting 4 students. Just see how I am proceeding. I have selected 1 student out of the 1 student, that is a particular boy, and further I have to select 4 students. So out of the remaining students, 7 students, I am selecting the 4 students. So this is the way in which a particular boy is always selected. Now in the next question, a particular girl is never selected. So I have to reject 1 girl. I don't have to consider 1 girl's name. So if I am rejecting 1 girl, that is not taken into consideration. I am left with 5 boys and 2 girls actually. So out of 7 students, I have to select 5 students, not 4 here. 5 because anyhow we have to complete a group of 5 students. Okay, so it is 7C5. And the last part you come, at least 3 boys to be selected. So we will just write this thing in English, then we will translate this into mathematics. At least 3 boys, what is the meaning? 3 boys and 2 girls. One combination can be 4 boys, 1 girl, because at least 3 boys, minimum 3 boys. It can be 5 boys and 0 girl. Why? Because in total we have to select 5 students. Now we can select either this way or this way or this way. Wherever either or is coming out, we just write plus plus plus. What is the use of plus? When the work is complete, in one particular fashion and we are doing the same work in another fashion, then it will be one way plus another way plus another way of doing the same work. So the work is selecting the 5 students. In this case, 3 boys. 5 boys are there. So 5C3 into the girls are 3. So 3C2. That is the case number 1. Or so plus. Be careful about the plus and into. Into means wherever the work is going on, you just multiply. You see, 5 students have been selected. The work is complete now. Now I will write plus because we are doing the same work again in another fashion. 4 boys. 5 boys are there. 5C4 into how many girls? 3 girls. So 3C1. See, again 5 students have been selected. So the work is complete. Again I am doing the same work in another fashion. 5 boys. 5 students are there. 5 boys are there, out of which I have to select all the 5, and 3 girls. I don't have to select any girl. 3C0. Now you just compute the values of these combinations and you will get the exact answer. 5C3 you can write 5 factorial by 3 factorial into 2 factorial into 3C2 is going to give you 3 factorial by 2 factorial into 1 factorial. Simply you just expand the things and you will get the values of the number of selection under the required condition. So you are understanding this thing, you just write the values of these combinations and you will get the exact value. Now what property I am going to tell you about the combination coefficients. What's the property? You just see here, NCR is always equal to NC n minus R. What is the meaning of this? I am telling you, that is, if 10C2 is there, that can be written as 10C8. You just calculate, you will get the same value. Suppose in a question that 10C3 is given and it is given 10Cx. Can you tell me what's the value of x here? Easily, you can just write 3 plus x is equal to 10. So you can get the value of x is coming out to be 7. Use this property, that will be very useful apart from the basic problems of combination. Hope you are understanding it. We will see in how many ways different things can be selected out of a given combination of things where certain things are repetitive. And the main difference from the earlier problem in today's problem is that we are selecting certain number of things in which certain things are repetitive. Earlier what we did, we were selecting all the things at a time. So see here the question, the representative question is different words are made with the letters of word mathematics taking 4 letters at a time. If we have take all the letters at a time, that is not a problem, very simple question. But we have to take 4 letters at a time, and in the word mathematics certain letters are repeating itself. So firstly we'll see what is the combination of mathematics, what it is consisting of. So you see here 2 m's are there, okay, 2 t's are there, and 2 a's are there, okay. And apart from that, the letters which are single non-repeating is H, E, I, C, S. So in total we got 1, 2, 2, 2, 6 plus 5, 11 letters, out of which a combination of 2, 2, 2 is there. So we have to take care of that. So firstly we will be selecting the things. We will be selecting the 4 letters and then the 4 letters will be arranged to find the total number of words. Okay, so firstly we will doing the problems of combination, selection, and then arrangement, that of permutation. See what is happening here. How many combination we can make here? Case number 1. If we select two alike, because I have to select 4 letters. 2 alike means 2 alike, 2 M's, 2 T's, 2 T's, 2 A's, like that. So how many alike groups are there? 1, 2, 3 group is there. So out of that 3 group, if I am selecting 2 groups, I am with 4 letters, because each group is consisting of 2 letters. 3 groups are there. Here 3 is meaning not 3 items, 3 letters, 3 groups. Out of that I am selecting 2 groups. So I have selected 4 letters. Then 4 letters can be arranged in, this is the selection, and these 4 letters can be arranged in 4 factorial ways divided by 2 factorial into 2 factorial. Why? Because 2 are alike and 2 are alike. So this is case number 1, 2 alike and 2 alike. Total number of words is this. Total number of selection is this. Case number 2, 2 alike, 2 different. What does this mean? Out of these 3 groups, alike groups, I have to select one group. 3C1. One group means 2 letters have been selected. Further, I have to select 2 letters. So how many 2 different letters are there? 1, 2, 3, 4, 5, and I have selected one group. So 6, 7. 7 different items are there. So out of that 7 items, I will be selecting 2. This is one group, that means 2 items. This is 2 different letters, so total 4 letters. Now if I have to arrange these things, that is 3C2, 7C2 into 4 things can be arranged in 4 factorial ways, but one group is repeating. So it is into 4 factorial by 2 factorial. And the case number 3, you see, all 4 different. How many different things are there in the letters of word mathematics? 1, 2, 3, 4, 5, 6, 7, 8 different things are there. Out of 8 different things, I have to select 4 different things. So 8C4, this is just the selection. Now after selection, I have to arrange them 8C4 into 4 factorial, because all 4 different, nothing to be divided by, because no repetition is there. So now the total number of ways of making the words with the letters of word mathematics, taking 4 letters at a time, is this. This is one way, plus this, plus this. Why? Because the work is complete here. Work is complete here. So plus, plus, plus. So what is the actual answer? It is coming out to be 3C2 into 4 factorial by 2 factorial into 2 factorial plus 3C1 into 7C2 into 4 factorial by 2 factorial and plus 8C4 into 4 factorial. You just sum all these things and you will get the number of words which can be made with the letters of word mathematics, taking 4 letters at a time. So be very careful when dealing with not taking all the letters at a time. We will see very important and very interesting problem, the problems of finding the rank in dictionary. Suppose a word is there, random, and we have to make different words with the letters of the word random, taking all at a time, and now these words are arranged as in accordance with the rules of dictionary. Then what will be the actual rank of the word random? We will just see that random word is consisting of the letters R, A, N, D, O, M. I am just giving you a technique. You follow that technique and that will make finding the rank very easy. you arrange these letters alphabetically. Alphabetically, A will come first, then D, then M, then N, then O, and then R. Okay. Now the technique is that you take first letter at first place. If you fixed A at the first place, the remaining 5 letters 1, 2, 3, 4, 5 can be arranged in 5 factorial ways. Why I am telling you this? All the words starting with letter A will definitely fall before the actual word random. So all the words starting with letter A is 5 factorial, that is 120. 120. See here, number of words starting with the letter A is 120. Same way, if you just select D, what technique I am following? I am just picking up the letters from this alphabetical order. Firstly, I have picked up A, then I will go for D. D, same way, D at the first place, remaining 5 letters can be arranged in 5 factorial ways, that is 120. Then I will go for M. Number of words with the letter M, starting with M, is going to be again 5 factorial, and that is 120. Then with N, 5 factorial, that is 120. With O, this is 5 factorial, and this is 120. What technique I am following? That whenever the first letter is coming R, I will cancel it out. Now I have to write R. I will cancel this. Why? Because R is the first letter here. Now I will pick 2 letters. R at the first place and the first letter here. It is RA, which is the actual position, RA. So this will be cancelled again. So A is again over. Now I will start with RA and the D. Okay. The number of words starting with the letters RAD. How many words are there? Because RAD will definitely fall before RAN. That is why I am finding 3 letters have been fixed in the first 3 places. Remaining 3 letters can be arranged in 3 factorial ways. What is that? 6. So number of words starting with the letters RAD is 3 factorial. That is 6. Now I will write RA, this is M. Of course this is RAM is before RAN. So words starting with RAM is 3 factorial. 3 places have been fixed and remaining 3 letters can be arranged in 3 factorial ways. That is 6. Now I will write RAN according to this order I am going. And RAN is the actual word. So this will be cancelled. Okay. Now N is over. Now I will start with RAN, and then D. Okay. The first letter is D here according to alphabetical order. Why? Because A we have used, and the letter which is coming in this order, D is coming here. That is the actual. So this will be cancelled. So now D is over. Okay. Now I will start from here. RAN D. RAN D, and then I will pick M. Okay. According to alphabetical order. Then how many letters are left over? Letter left over is 5. I have used 1. 1 factorial. That is 1. So next I will pick up RAN D O, which is actual. So it will cancel, and the last letter is RAN D O M. This is the actual letter. Now see, sum up 120, 120, 120 5 times, that is 600, 612, 13, 14. So what is the rank of the word random of all the words made with the letters of word random? Different words have been made, and they are arranged as in dictionary. So the actual rank of the word random is coming out to be 640. Just follow this technique, cancelling out, actual letter is coming out, you just cancel, start from the next, and this technique will be very easy and you will get the rank very easily. Next question is, different words are made with the letters of word IIT, JEE. Now these words are arranged as in dictionary. Now we will see what is the rank of the actual word IIT, JEE. So I just said you arrange in alphabetical order. This is E, then E, then I, then J, and then T. This is the alphabetical order, and now we will start. How many letters are there? 1, 2, 3, 4, 5, 6. So if I start with first letter E, that means number of words starting with letter E. E has been fixed. Remaining 1, 2, 3, 4, 5 letters are there. That can be arranged in 5 factorial ways. But out of the remaining 5 letters, 2 I's are there. Repetition of 2 I's. So we will write it as 2 factorial. So it is coming out to be 60. So number of words starting with letter E is 60. Now I will jump for next thing, that is I. No need of taking the second E because that is the same thing. I, which is the actual letter. I said you, wherever actual letter is coming, you cancel it out. Now you go for I, E. Okay, I, E. Wherever, whatever letter we are cancelling, we start from next letter after that. I, E. So if I am using I, E, the remaining 1, 2, 3, 4 letters are there. That can be arranged in 4 factorial ways, that is 24. You luckily see that no repetition is there in the remaining letters. Next I will take I according to that alphabetical order, and that is the actual word, so it will cancel out. Then I will take I, whatever letters cancel out, we start from the next. I we are taking, then E. Okay, so I am using this 3 letters I, E here like this. Okay, so 3 letters are remaining and that can be arranged in 3 factorial ways, that is coming out to be 6. Okay, then next I will take I, J. So I, J, and remaining 3 letters are E, E and T. That can be arranged in 3 factorial and by 2 factorial. Why? Because 2 E's are there. So this is coming out to be 3. And then it is I, T. Okay, that is the actual, so it will cancel out. Next I will go for I, T, then E. Okay, so I, T and E I have used. 2 letters E and G is left over. That can be arranged in 2 factorial ways, that is 2. And next is I, T, J. Okay, that is the actual, see here. So this will cancel out. Then I will go for I, T, J, E. That is again the actual. Cancel out. And the final word is I, T, J, E. That is the final word. So the rank is coming out to be 60, 84, 90, 93, 95 and 196. So if different words are made with the letter of word IITJE and they are arranged as in dictionary, then the actual rank of the word IITJE in the dictionary of these words will be 96. Just follow this technique.
If you like my videos, please subscribe my channel and share my videos.